Hi kids! It's time for lesson 16. Finally, I'm getting back to this one. I skipped it, but I am coming back. And this one, it kind of is using what you have seen in lesson 15 with the right triangles and the flip and rotate, and then the sum of the angles. So if you do happen to have the work that we did on the previous video for lesson 15, this is kind of handy because when you're creating the sum of the angles that are not included in the right angle, it's going to look something like this, where you might have a 60 and a 30 on either side of the 90-degree angle. So here's the 90-degree angle, and then on this side, if the angle is faced this way, it could have a short one. If it's faced this way, you could have two 45s. So anyway, the idea is that we are adding up angles and that the total sum would be 180 on a flat line. So, and check out lesson 15's video if you want to review that. It would be nice if you had a straight edge of some sort, a ruler, a protractor. We're not going to be measuring any angles, so you can just have a little ruler, my favorite broken ruler, that's a little extra short. That would work just fine. A regular ruler will work just fine as well. So let's get started. Use the coordinate plane below to complete the following tasks. Draw line segment AB. Notice it doesn't have arrows. That means it's line segment. So we're going to stop at those points. Then plot point C at 0, 8. Don't go anywhere for X. And then go up for 8. So we're going to be right here at point C. Now draw line segment AC. So connect. Now you have to explain here, okay? Explain how you know angle CAB, that's what that means, is a right angle without measuring it. So if you look at what you did in lesson 15, we had created right triangles on either side, but they have to have the same dimensions. Now, some students, when I was walking around in class and I saw, okay, maybe they didn't quite have the same dimensions, but you do have to be very precise. So take a look at, let me use a different color here. So if I go, say, down 2 and over 1, 2, 3, 4, 5, okay, down 2 over 5. If I go over 2 and up 5, 1, 2, 3, 4, 5, then what I have are these two symmetric, they're identical right triangles, which have been like flipped and rotated, okay? And they're the angles, this angle here and this angle here, that's where we get those other two angles that could add up to the sum of the other 90 degrees, which means that this is going to be the 90 degrees that they're asking about. How do you know that? Well, because I can create right triangles about, remember that, about the right angle, and I can use the coordinate plane to do that. So let's write our explanation, and we can move on to the next one. So write this, angle CAB is a right angle because I can draw the triangle that has then line segment AB as its long side, right here. Line segment AB as its long side. Notice there's no apostrophe there because it's not, it is. It's a possessive. As its long side. Now, the length, this is where you start talking about the length and the height. So the length is 5 and the height is 2. Length. The length is 5 and height, Height, is 2. Okay, now when you remember those templates that we didn't cut out, when you slide, so when I slid the triangle, slid it over left and rotated, I knew the two acute, so cute, angles will form a 90-degree corner. The two angles, the two adjacent, ADJACENT, the two acute adjacent angles will create a 90-degree angle. Okay, so when you use the coordinate plane and you use these other right triangles on either side, you're creating this corner when you move, flip, rotate those triangles on either side. Okay, so let's do another one. This one has it's already done for you, so we just have to explain. So Sean drew the picture below to find a segment perpendicular to line segment AB. Okay, so he drew this. We've got AB, and he's trying to find a segment that's perpendicular to line segment AB. So explain why he's correct when he drew this one. Okay, so how can we come up with this one if I just have this in the beginning? So it's all about creating these triangles, remember. Okay, so if this is what's already here, okay, you can slide it and rotate it, slide it up and rotate. Sean is correct, because he slid and rotated the right triangles okay, and these also, it's the same, 2 and then 1, 2, 3, 4, 5. He rotated the right triangles with base of 2 and height of 5, and the two acute angles will form the 90-degree right triangle. And so that is right here in the corner. Okay, so remember the sum of the angles of all three in a triangle are going to be 180. Okay. Whew. So it's kind of a heady topic today. Heady means it's like a lot of thinking, and if you don't exactly see it, you'll survive as a 5th grader. You'll get a chance to do more later in higher math, but just try your best today. Okay, next one, use the coordinate plane below to complete the following tasks. Draw line segment QT. It's a QT. Okay, and then plot a point, call it R, at 2, 6.5, 2, 6.5. Let's call it R and label it to the left. Draw line segment QR. Go ahead and do that. Ooh, look at that nice angle. Explain how you know angle RQT RQT, they usually put the center vertex point in the middle. RQT is a right angle without measuring it. So here you might be looking at your sides of the angle that you created, and you're thinking, how can I create something that will show me what these other angles are? So use the graph. Use the graph. Let's go straight down here and over to here so that I see I've got a 3 by 1, 2, 3, 4, 5. So I've got a 3 by 5 right triangle. Okay. Now, if this is the wider of these two angles, then when I flip and rotate, I'm using the narrower side to create this triangle. And it's a symmetrical triangle, it's just flipped and rotated. Okay, so this is the wider side, and this is the narrow side, and this narrow side matches this narrow side here. So this one matches this one. And then this one is my right angle, which takes up 90 degrees out of the 180. And then this is the wider angle, which matches this one. So they're symmetrical triangles, they're just flipped. Okay, and so then because when I add up these two other angles, the only way I can create this 180 degree arc right here is to have a sum of 180. Okay, so if that's half, then these two have to add up to the other half. But when I use the grid like this, I'm going to get maybe the 60-30. Okay, so write your explanation over here. I can draw a right triangle. And slide and rotate it. Then the two acute angles, acute is less than 90, okay, so this is going to be the 90, and then these will have to be less than 90. We'll make 90 together, 90 degrees together, leaving me with 90 degrees for angle RQT. Okay, so the next one, I hope it's getting clear. The more we do it, the more it might become clear. Compare, oh, this is where it starts to maybe get a little harder, sorry. I didn't make this program, so not my fault. Compare the coordinates of points Q and T. So let's write them down. What's the difference of the x coordinates and the y coordinates? All right, let's check them out. Q is 3.5, 4. T is 6, 5.5. I know you guys can hear the air conditioner. I'm sorry, it's really loud. And I was trying to make it turn off too. That's what I get. Okay. So what's the difference of the x coordinates? And what's the difference of the y coordinates? So the x coordinates are how far apart? Let's just do the math. 3.5 to 4.5 to 5.5 to 6. So they're 2.5 apart. Okay, 2.5 difference. Not grammatically correct, but there you go. At y coordinate. Okay, those are what? From 4 to 5.5, that's 1.5 difference. I'm just going to abbreviate. Okay, so just notice that. That's all they want you to do is just notice. Like, does it have anything to do with anything? Not yet. But now we're going to compare the coordinates of points Q and R. Okay, so we already have Q, 3.5, 4. And here's R. R is 2, 6.5. Okay, so now let's look at our x coordinates, and they are, well, the difference from 2 to 3.5 is 1.5 difference. And the y coordinates, I wonder if you could guess what the difference would be. Y. 4 to 6, that's 2, and 2.5. Oh. Huh. Very curious. Interesting. Interesting. You might be going, I don't see anything interesting. Mrs. Setness, it doesn't make any sense to me. Let me point something out. In our figure up here, okay, we have these random points, or so it might seem, but when you flip and rotate, when you slide these points, they really do have something in common, okay? Let's talk about that here. What is the relationship of the differences you found in parts E and F to the triangles of which these two segments are a part of? So let's write this out just so you can try to understand the whole thing as we put it together. The difference of, and I'm going to abbreviate again, of the x in Q and T, Q and T, 2.5, is the same, or was the same, as the difference between the y coordinates of Q and R. Okay, so just real curious, the x is 2.5 here, the y's are 2.5 here. So what about the other side? Then the difference of y in QT was the same as the difference between the x's in Q and R, in QR. Okay, so the thing is, the numbers flipped. So just notice that. That's really what should stand out for you. And let's see, beyond that, now this last one is just kind of an example of, if you understand this, then you can apply it. So line EF contains the following points. Here's point E, here's point F. What do I do with that? Nothing. Go on here. Give the coordinates of a pair of points, points G and H. So they're saying, what would the coordinates be, such that line EF is perpendicular to line GH. Now, apply this principle here so that this line that you're creating is perpendicular to the one that was already there, and apply this rule or this phenomena or this math theory that if you use the same numbers, they're going to switch places. Okay? So we're going to use all the same numbers. We're going to have a 4 and a 1 and an 8 and a 7, but they're going to switch places. So for the 1 point, I'm going to switch the x's and y's, and for the other point, I'm going to switch the x's and y's. So if I take point E and I look at the x and the y, I say, well, I need to have the x become a y. So, and I'm going to switch it to the opposite place. So I'm going to take my 4x and I'm going to put it on the y. And then I'm going to take the y and I'm going to put it on the first one. And then I'm going to go to this and I'm going to take my 8, which is the x, and I'm going to make it the y on the other figure. And then I'm going to take the y and make it the x on the second point. So this is how it would end up, and the reason that you can do it, you just make the x to the opposite y, and then the y to the opposite x. And if I was 10, I would never, ever, in a million years, not in a million years, probably be able to figure that out. So I am glad I can help you with that today. If it's helpful, click subscribe and come back again on another video. See you. Bye-bye.